Hello, everybody. This is the Red Wine Project with all of my partners here. My name is Damien Torado. I'm also with Cade Patterson, Hudson Hansen, and Vivek Dunga, and we'll be starting right now. So first things first, we want to start with importing all the required libraries. The reason we're doing that is so that way we can use the commands to make things such as graphs, tables, and also open up many data frames.
The second thing that we do is we are reading the CSV files and printing the first 5 rows. And we do this to obviously see the data frame. And then we append the quality as binary features where 1 would be equal to good and 0 would be equal to bad. This was part of the project qualifications to make 1 is good and 0 is bad. We then copy the data frame to wine and then print first 5 rows of the data set over again.
Now, when we go down to getting info about the wine data frame, the reason we're doing this is because we want to know exactly the info about the data frame itself. As you can see, it displays that there are 13 columns. We need to know that because we need to know that there are 13 other different types of information being taken. Also, if you look, it'll go ahead and explain what each and every one of those columns is. So now we know we have fixed acidity, citric acid, chlorides, and so much more. I feel like that's very important to know when it comes to wine because you need to know all the ingredients mixed inside of it.
Next thing we did was gain the basic statistical information about the data frame. We do this by using wine.describe. And the reason why we use describe function is just to get a more descriptive detail of all the different categories in the function or the data set.
Here we display the scatter plot between all the columns of the data. So as you can see, by using the SNS feature, we were able to make a wine plot of every different possibility. So if you want to go scroll down just a little bit more, yeah, you can see the variations of the data frames, the data frame graphs that we collected here.
The next thing we did is that we displayed the heat map. So first thing we had to do was compute the correlation coefficient for the heat map, and then we had to generate the heat map and then if you can scroll down a little bit, the heat map will be in different shades of blue depending on the number that it gets, and everything in the heat map is provided that was in the original data set.
Now, with that being said, now that we have all these different things in our data set, we want to convert them all into a proper standard unit. And the way we do that is, as you can see below, we get almost every type of a column. We're going to go ahead and convert that into the standard unit. And then once we actually get that into standard unit, we want to make another data frame in which we're going to append that, like it says, and append them into a data frame. So that's what we're doing. We're getting those all in standard unit and then making them into its own data frame. So we have that information for it right here.
The next thing we're going to do is randomly shuffle all the rows in the wine data set, and then we are going to separate them into training set 70% and test set 30%. So the first thing we have to do is find the length of the data set, wine, and we'll put that under pH. And then the second thing we have to do is shuffle all the data set, and then we will replace it with true. And then, then we separate them into the 70 percentile and then the 30 percentile, and then we print the outcome below.
Now here, he assigned us to index and pick the important columns and standard units from the training set. The way we do that is, if you can see, we actually have to use the iLocation function. So in the xtrain is equal to training set iLocate. Here we're getting column 13. We're getting its values inside of column 13. And then from there, we're going to go ahead and reshape the 1D array into a 2D array using the same function down here, but just with a different variable name. As you can see, we have xtest is equal to test set.ilog, and that's still the same column, however, but just a different section.
Here, all we're doing is transposing xtrain xtest into and storing them into xtrain and trans and xtest trans, and we're going to add a row to both of them. this is pretty straightforward, just using xtrans and MP. We have to use the MP function here, and then we also have to use length function as well. And then once we're done, we just print this to the outcome.
Transpose. Oh, I'm sorry. Here we're going to go ahead and create the 2D NumPy array with the zero stored inside. In order to do that, there's actually a function. We're going to go ahead and call the NumPy.zeros function. And then from here, we're going to go ahead and get the 12 to the 1. And then data shape is 12 to 1.
Next thing we're going to do is implement the gradient descent algorithm by minimizing the cost function and find the value of theta. So the first thing we have to do is put the total number of the iterations, and we have to put a 1 in front of it, and then an extra 1 after it to make sure that it includes the entire data set that we want. And then if you go down a little bit, we use FT, ST, CF, all different functions. We use a cost function with the different equations, and then we end up putting theta to get our solution.
Here we're going to go ahead and test the model on the training set. So what we're going to do here is similar to we're still using that NumPy function, as you can see. So we're putting the Y train prediction equal to the NumPy zeros, but this time we're going to go ahead and calculate the zeros of the M train itself. We're going to do that again down here with the H theta is equal to NumPy transpose theta, and so on forth. And then here, as you can see, we have the for loop that's going to be comparing the prediction. So we have 4J in the range of M train, and then so on and so forth.
And after that, all we're going to do is plot the cost function versus the number of iterations. And all we have to do here is use the plot PLT or plot function. And we have to make sure that our X label, Y labels, and title are all correct and show exactly what we want the people to see in our graph.
We're going to evaluate our model on training set and test set by finding accuracy, precision, recall, and F1 score. Now we're going to do everything again by using scikit-learn library. Over here, we are printing the first 5 rows over here. Then we are choosing the required column required for logistic regression. Then we are simply changing our columns into the standard unit by using the function from sklearn library. Then we are splitting all the data into training set and test set. Now we are simply using our logistic regression object from the sklearn library to train our model. Then we can simply test all this result on our model. And one thing we notice over here is by using the sklearn library, we can do like really complex job in very few lines of code. Thank you so much.
Here we have the project management video, which is going to be just a quick paper that explains exactly what we were getting out of the statistics here in the wine study and what the group members did to contribute to that. Scrolling down just a little bit here, we have a quick introduction on the project itself. Here in this project, we wanted to go ahead and open up a wine file that consisted of 12 columns. And out of those 12 columns, we were collecting different statistics about each wine, such as how much alcohol was poured, how much sugar, how much free sulfur dioxide, and many other things that contribute to the wine itself. Based on the different properties we had, we were determined to find a final wine quality, like on what was the best wine for other people. Now, our group is planning to use a technique of a machine such as Python and Jupyter Notebook to go ahead and collect this statistics using Jupyter to collect the physical properties and chemical properties of the wine itself through that wine graph. Now, if you want to go ahead and scroll down just a little bit more, we have the responsibilities of each group member. Obviously here, I'll let everybody go ahead and read their role, starting with...
Hello, I am Vivek Dhungana, and my responsibilities in this team was to implement a gradient descent algorithm and use logistic regression in order to determine the wine is good or bad.
I'm Hudson Hansen. I was responsible for testing our model and training set test and evaluating the model on both of the set.
I'm Kay Patterson. I index columns, I stored them, I created the 2D NumPy array, and I double-checked code solutions and fixed any errors that showed up.
Similar to Kate, I also contributed to fixing some of the errors that were showing up, and I also helped design the graphs and tables necessary.